7th grade. So, what I want you guys to recall from math degree is that a relation is a rule that relates to quantities. All right? It pairs the elements in one set, we'll call that set A, with elements in another set, we'll call that set B. All right? Set A, the set that's being paired with the other set, is called the input. And what we're going to be calling that in this class is the domain. Okay? And set B, which is the output, the set that we're pairing stuff with, that's called our range. Right? And when we get going into this, the ability to identify the domain and the ability to identify the range of a relation or a function, which we'll be talking about shortly, is going to be very important. All right. So typically, what you'll see is we're sort of in that math where we are above, like saying the output value is 2 more than the input value. Right? Talking about the output and input for the domain and range verbally like that. What we're going to get more into and showing it numerically, talking about it graphically. All right. So, like for instance, okay, so the input, that's going to be your x value. All right. So that's something that you want to make sure you know. The domain, this is your x values. The range, that's your y values. Okay. So x values and y values. Okay. That's how it works. All right. So when you're looking at these, and if you can't see them, these pairs of numbers down here are 0, 2, 1, 3, 2, 4, 3, 5. Okay. Our input are the x values, 0, 1, 2, and 3. Our output, or our range, is our 2, 3, 4, 5, because they're the y values. All right. If you look at a graph, again, our domain, or our input, but again, we're referring to it as domain, are our x values. So at 0, this is x equals 0, that's the input, or the domain. The range value is what? 1, 2. That domain here, that x value is 1. The range value for that is 1, 2, 3. Domain here is 3. Range is 4. Domain is, I counted that wrong, my fault. Domain here is 2, and the range here is 4. Domain here is 3 and 5. So this graph shows the set, this set of input and output, or domain and range. All right? And then this is just an equation that would represent this relationship. Okay? So, a function, and I think what I did for you guys is, I'm not 100% sure, I think what's written in red is stuff that you should write down, or not written in red is stuff that you should write down, so you gotta know all this stuff. Alright? So, a function is a special type of relation. Alright? And the definition of a function is a function f from set A to set B is a relation that assigns to each element x in set A exactly one element y in set B. I'm going to let you write that down, and I'm going to explain what that means, because if you read it too fast and don't look at a picture to go with it, it can sometimes get confusing about what it actually is saying. Okay? Alright. I'm thinking you guys might have seen this. Maybe, I don't know. I haven't thought that through yet. But, so, what this is saying is a function, it is a relation, and it's taking values from set A and it's mapping them to set B. But the trick is, and the important part is, that it is mapping it to exactly 1. Okay? So if you look at this picture right here, which would be beneficial to draw, alright? You have set A, which is our domain. You have set B, which is our range. Alright? So, first of all, can someone just looking at that identify what our domain is for this relation? What values are in our domain? 1, 2, 3, and 4. Thanks, Mo. So our domain, the way you can represent that is 1, 2, 3, 4. And how do we know that? Well, okay, it tells us that set A is our x values. And it tells us domain is set A. Well, those are the 4 numbers that are in our set A. So what about our range value? What was our range value? 6, 7, 8, 9. Okay? So, here's the trick. Because we can do something up here that makes this not a function. But the reason this is a function is because if you look at our domain, 1, 2, 3, and 4. 1 maps to exactly 1 element, which is 6. 2 maps to exactly 1 element, which is, in this case, that looks like it's pointing at 8. 3 maps to exactly 1 element, which is 8. 4 maps to exactly 1 element, which is 9. This picture, I would draw this picture. Because I'm going to draw another picture that shows you one that's not a function. Okay? So, I want to show you guys a picture that looks almost identical, but it's not a function. And I want you guys to try to tell me why. Keeping in mind that in order for a relation to be a function, every element in X, or every element X in set A maps to exactly 1 element Y in set B. So I'm going to draw almost identical picture. I want you guys to tell me why this is not a function. Why would this not be a function? Because 4 goes to 8 and 9. What does the definition of a function say about the values and the elements in set A? It can only map to. And the word map to, it's the map phrase of like it goes with, or it gives you, like when I plug it in, it gives you that. But the element 4, as Mo said, maps to 8 and 9. How many elements is it mapping to right now? 2. But the definition of a function says it can only map to 1. Now, this is a relation. This is still a relation. It's just not a function. Okay, so not what? Not a function?
No, like that.
Yeah, it'd be good to have this. This is not a function. it is a relation. Okay, so a relation, so you can have a relation that's a function, but you can't have a function that's not like, okay, so something can be, how was the best way to say it? Something can be not a function, but still be a relation. All right? And again, if we looked at that picture that I just drew that's not a function, the domain would still be what? Yes, the domain is still 1, 2, 3, 4. The range is still 6, 7, 8, 9. It's just not a function. Okay. So, just to sort of put a clarifying thing, if you have an x value or a domain value that maps to 2 y values or 2 range values, it's not a function. All right, so what we're going to look at here are a couple of examples. All right, so here's an alternate definition, and you don't need to write down this. What you maybe eventually want to write down, not yet, is this though. So an alternate definition of what a function is a set of ordered pairs in which no 2 different pairs have the same x value. All right, so what that means visually is if you're looking at this table right here. So this is the table of a relationship. See what's highlighted? Why is this not a function? There are 2 trees. Right here it says a set of ordered pairs in which no two different pairs have the same x value. So you can't have 2 3s. Because right here you see, we said it maps to exactly 1 y value. Well, 3 maps to -1, and it's saying 3 maps to 4. That's 2 different y values, not 1. Does that make sense? Yeah. So I'm going to ask you a question now. I'm going to put it on the table. I'm going to ask you guys a question, and I want you to tell me. I want you guys to tell me why this is a relation. Or no. I want you guys to tell me if this is a function or not. All right. First question, what are my domain values? They should be. So my domain values are -2, 3, 4, -7, and 6. What are my range values? 3, 4, 2, -5, and 4. So my question is this a function? Raise your hand if you think this is a function. Well, why do you think it is a function? Okay, that's fine. So he said, you're saying no x value goes to 2 different y values, right? I think that's what you said. Yeah. Yes, there is no 1x that goes to 2 y's. So, is there anyone that still thinks this isn't a function? Where could you have gotten tripped up at? There's 2 4s, right? Well, no. So in the y values, there's 2 4s. All right. nowhere in the definition of a function does it say that you can't have the same y value show up more than once. Okay? What it says is that you can't have an x value show up twice and have it go to two different y values. So this is a function because -2 only goes to 3, 3 only goes to 4, 4 only goes to 2, and so it doesn't matter that you have 6 and 3 both going to 4. It doesn't matter. It's still a function. Now we'll talk about that later on because that means something. All right. So we'll talk about that. I don't know, maybe next week. Now graphically, what does all this mean? Like if we're looking at a graph or something, how do we know that it's a function or not a function? All right. Now here's my expectation. I expect that you know that a function is a function because every x value maps to one y value. And I expect that you know that a relation is not a function when one x value maps to more than one, so 2 or 3 or 4, more than one y value. This, what I'm about to tell you, is a nice little test. All right, let me check on something real quick. If I have. Okay. All right, so this is a nice little test. Graphically, this means that no 2 points on the graph of a function in the coordinate plane can lie on the same vertical line. Okay? Because if I draw a vertical line, it has the same x value but a whole bunch of different y values on it. Right? So right here, if I take this, so let's see, this red line, if I just move this red line, let me actually draw a red line. All right? So let's do this. Let's go. And that's straight. This. So if I take this red line, what it's saying is if I move it through each of these, does this touch any other point? No. Does this touch any other point? Because there's a point right there. No, these are points. So there's this. Is this vertical line touching any other points? Is this vertical line touching any points now? The other one's down. Yes. But
I guess we were saying that that line can't have any other points.
correct. As long as if I draw a vertical line, so typically what you'll do, you look at the graph and you guys draw a little imaginary line at the end. If I draw a line here, and I can just sort of take that line, I just move it this way, and it never touches more than one point at one time, it's a function. And so graphically what this is saying is, this means that no 2 points on the graphic function in the coordinate plane can lie on the same vertical line. And it's actually called the test. It's called the vertical line test. Huh? Well, so the vertical line test helps, right? But like if I were to ask you, is this a function, and I give you a graph and I say explain, I don't want you to say, so what you could say is, yes, it passes the vertical line test. But what I want you to say is, yes, because every x value maps to exactly one y value. I want you to know the definition. Because a lot of times what I find is people understand the vertical line test. And the thing is, you're going to get a horizontal line test later. So the vertical and horizontal line test tell you two different things. So if you can understand what a function is, or what the graph of a function is without saying, oh, it has the vertical line test, then you're better off. Because what you can do is this. Let's say this red line, let's say that you just had those dots. That red line wasn't this. And I was like, this is a test question. I was like, is this a function? Well, you can think in your head, okay, passes, 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 passes. Okay, I know it passes the vertical line test, so this is a function. And it's a and I know the definition of a function. Every x value has to be one y. That makes sense? So there we go. Good? to write this down. Wait, let me actually state like the explanation. What do you want to write down? Okay, so what I would write down, if you want to remember, like, to remember that definition, is what you want to, if it is a function, you would want to say, it is a function, and thinking in your head, okay, you think, okay, so I'm gonna put in like, I'll put like a thought bubble. Passes vertical line test is a function because so you think this, and it's because every x value maps to exactly one y value. All right, and then you can always switch it around. It is not a function because it doesn't pass the vertical line test, which means so there it is not a function because not every x value maps to exactly one y value. Alright, well, the nice thing is, now you can just go watch the notes and you can always see it if you ever forget it or you lose your notes. Alright, you good? So on your homework tonight, you guys will get some practice with that because it's going to ask you, is this a function or is this not a function? Alright. Oh, well, okay. So we're going to get some practice right here. Okay. So I want to identify some relations that are functions. The input value x is a student's ID number, and the output value y is that student's score on a physics exam. Is this a function or is this not a function? So, great. Okay, so there we go. Your student ID. All right, so you have your student ID. So I'm passing back your test. Did you get 2 different scores on it? Did you get 1 score on it? You got 1. You usually don't get 2 scores on a test. You got the score you got. You get your physics test back. It's going to have how many scores on it? How many scores? How many scores? How many scores? All of your, so his student ID, so if I posted your grades up over here, Mo's student ID is here. There's going to be 1 physics test score across from his name. All right? Ronaldo's name, his student ID, is going to have 1 score across from his name, right? Brianna's name, 1 score across from her name, right? So each student ID, which is your domain, is mapping to 1 physics exam score. So is this a function or not a function? It is a function. All right? It's just a little trickier because it's a word problem and you're not actually visualizing student ID, student ID, student ID, which is your domain, mapping over to all the exam scores. Okay? So this is a function. All right. B. Take a look at that real quick. And I'll move it up some. Is this a function? So raise your hand and tell me why or why not. Why? -8 doesn't show up again, it only goes to -5. -5 only goes to -4. 0 only goes to -3, 3 to -2, 6 to -3. And it does not matter that there's 2 -3s over here. Right? Because the thing that matters with the function is that the x values map to one y value. And it does. So this would be A. All right. What about C? How do we know it's not a function? And don't say because of the vertical line test. Because in your head you're thinking, okay, it passes the vertical, it does not pass the vertical line test. Therefore, alright, so yes, it is not a function because in your head you think, okay, it doesn't pass the vertical line test. And you write down because there are x values that map to more than one y value. Alright, so when you're not a function, because there, you don't have to. This is what you'll be doing for your homework. Alright, not a function because there are x values that map to one, no, not one, map to more than one y value. Okay? And then, if you want to, at the end on your test, you say, I applied the vertical line test. Alright? I believe that the first couple questions on your homework tonight is exactly that. Figuring out, if something's a function or not a function and providing an explanation. So obviously for a function you have to say because each x value maps to one y value. Yes. Yes. All you guys' homework would typically be out the board. Alright, questions? Alright. So, is that readable or should I throw it in the lights? Alright. Yes, this is important. I want you guys to understand this. Let's see. Yeah, I want you guys to write this all down. Actually, write down these first three bullet points, and then hold off writing this up so I can talk about the first thing after writing. All right. So, you guys know. Okay, most of the time, you guys are doing going through math your entire life and whatnot. And what we've been seeing is y equals this, y equals that, y equals this and that. All right. We are going to sort of start getting away from that. Are you going to see y equals? Yes. But when we get higher up in the math, we like to make things a little bit more confusing and make you learn new stuff. All right. And what that new stuff is called is function notation. Okay. Function notation is represented by the symbol, and that's just an f. So f parenthesis x parenthesis, which is read f of x. Okay. So it's read f of x. And the way we interpret it is it's interpreted as the value of the function f at y. Or at x, not y. It is interpreted as the value of the function f at x. Okay? So because f of x corresponds to the y value of f for a given x value, we can say y equals f of x. So in the very, 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 very short story, y is the same thing as f of x, and we're going to most of the time replace y with f of x, and we're working with functions. All right. Yeah, you guys can just go ahead and keep writing it on, as long as we're paying attention. So, what you have right beneath the first 3 bullet points is what you're used to on the left, which is an equation. Y equals negative 6x. Where you plug in your x and get your y. The related function is f of x, so the function of x equals negative 6x. It's the same thing. F of x is y. It's just we are noting it different. Alright? And since x can represent any value in the function's domain, it is called the independent variable. Okay? In fact, you don't necessarily need to write this here at the bottom part. If you have already, finish writing it. It's not 100% important. Like if you don't write that down, you're not going to miss it. Yeah. So, what I really need you guys to understand is that f of x and y are essentially the same. All right, and I need you to understand that when you see this, it's read f of x or function of x. And all that means is that you have a function, and x is your variable. Okay? So if you saw this right here, sometimes what you'll start seeing is, it might say g of x. That just means that we have more than, like, we have multiple functions. I can replace f with g. Now this is like I'm saying, yeah, that function is called g. This function is called f. This function is called h. That function is called Jericho. All right? So I can call the function whatever I want. It's just typically f, g, h, something in that range. All right? So what does this all mean? Well, what this means is that we have functions that are written f of x. And we have a whole bunch of, like, there's an infinite number of functions. So we have this function right here. Okay? Look at this, already g. We've got word of f, and we call it g now. All right? We have the function g of x equals x squared plus 8x minus 24. We've seen this. It says find each function value. All right? So, we have g of 6. What does g of 6 mean? What are we going to do with this? Replace the 6 with x or replace the x with 6? We're going to replace the x with 6. So g of 6 is equal to, okay, as Mo just said, we're replacing x with 6. So instead of x squared, it's going to be 6 squared. Instead of plus 8x, it's going to be plus 8 times 6. That's 8 times x. Minus 24. Nothing changed with 24 because there is no x. So, do this. 6 squared is 36. Plus 8 times 6 is 48. Minus 24. Again, you can type all that into your calculator when you're doing homework, but it's going to have to be 36 plus 48. That's going to be 84. And then you have 84 minus 24 is going to be equal to, let's see, that's going to be 4 and then 60. So g of 6 is equal to 60. Pretty easy cut. Now, what you guys are going to see a little bit of is where we don't have just numbers. We actually have a variable in there. Okay? So, we define g of negative 4x. Okay? What are we doing? Instead of replacing x with 6, we're replacing x with negative 4x. Replacing, it with all that stuff. So, we're gonna have, instead of x squared, it's gonna be negative 4x. Great, notice I put everything in parentheses. Alright, instead of plus 8 times x, it's gonna be plus 8 times negative 4x. And then I still have the minus 24. Okay? So, negative 4x squared. Here's, I know that there might be, if I ask you guys what that is, what do you guys think that negative 4x squared is? Here's what I think that a lot of students do. I think a lot of students can do this. There we go. Negative 4 x squared. We get rid of the parentheses. Just get rid of the parentheses. Why not? Alright? What this means is we actually have to take that and go negative 4x times negative 4x. Okay? Negative 4 times negative 4 is positive 16. X times x is x squared. So negative 4x squared is 16x squared. You have to square the number, and you have to square the variable. So negative 4 squared times x squared plus 8 times negative 4x. 8 times negative 4x is going to be negative 32x. Minus 24. So we have 16x squared minus 32x minus 24.
Please excuse this interruption. Teachers, can I please get all attendance in for the day now? All attendance needs to be entered at this time. Thank you.
Okay. And just to look at this example, so you have g of 5c plus 4. Again, you're just going to take 5c plus 4 and put it in for x. Alright, so you would have, I'm not going to go all the way through this, but you would have, instead of x squared, you're going to have 5c plus 4 squared plus 8, instead of 8 times x, it's going to be 8 times 5c plus 4 minus 24. Well, do you guys want me to go all the way through this? Does you have it? Just in case. So you have that. You plugged in 5c plus 4. Okay? So what you're going to do is we have to expand this and then simplify. Okay? So I'm going to do a little bit of side math over here. We'll put it in mixed color. So 5c plus 4 squared, all that means is 5c plus 4 times 5c plus 4. Okay? So 5c times 5c is going to be 25c squared. 5c times 4 is going to be 20c. 4 times 5c is another 20c. 4 times 4 is going to be 16. So what I get, 5c plus 4 squared is 25c squared plus 40c plus 16. Does that make sense? All we did is distribute. So it's 5c times 5c, 25c squared. 5c times 4, 20c. 4 times 5c is 20c as well. 4 times 4 is 16. So once you distribute that, and guys, I would do that off to the side. Do it off to the side, and then you come back over here, you say, all right, so that's equal to, so I know this is equal to this, so I'm gonna put that over 25 c squared plus 40c plus 16, all right, but I also have this stuff, so I have to go 8 times 5c, that's 40c, plus 8 times 4, that's 32, minus 24. All right, and at that point, all it is simplifying by combining like terms. So you're going to have 15c squared, 40c plus 40c is 80c, 16 plus 32 is going to be 48, minus 24 is going to be positive 24. That's your answer. All right. So that's a lot. Typically, I'm assuming you guys know how to distribute stuff. So typically on a test, I'm not necessarily going to be like, all right, guys, I want you guys to plug in 5c plus 4 into something that has like 12 variable or 12 exponents and make you expand stuff. All right. Questions on that? How do you guys feel? A little bit. We probably have like one problem like that. Probably not overwhelmed yet. Hey, good. He's got a little bit more to go.
Just wait.
Alright. That, you just see something over there. Okay. Almost done actually. Okay. So, here's what. No.
You meant when you're real.
That isn't a problem. Alright. So, I want you guys to write this down just because it gives a good description of what this is. I know it's a lot. Alright, so this, I would say this is one of the more important things that you need to come away from pre-calculus knowing how to do. Is finding the domain algebraically of a function. I got a lot of here. Need some? Well, but then think about this. You're going to go home and know exactly what you're doing. And if you don't, you can always email me, but I will get back to you for Monday. We don't have school on Monday, so I can get issues up on that time. I'm not going to have to get access. Alright, so finding domain algebraically, again, this is one of the more important things that you're going to want to know how to do. Alright, this is going to set you up for success in your first college class. It's going to set you up for success in AP calculus that you're taking next year, so in college. So, when asked to find the domain of a function, you want to find a set of real numbers for which the expression used to define the function is real. Okay? So what do I mean real? I mean, if you type it into the calculator, it better not say undefined. Okay? So, just ended. I'm gonna put this back on about 1 second, guys. Alright, there you go. So, here's what you guys need to understand. In general, what you're going to be doing is your domain is going to exclude values typically what you're going to do is you're going to exclude values from the domain that cause you to divide by 0 or cause you to take the even root. So usually square root of a negative number.
My brain just picked up everything you said and it started going from my hand.
Now, divide by 0 is what?
Divide by 0 or take the even root of a negative number. And we're going to quickly talk about an even root. Alright? So go ahead and get to where you're writing down the first example. Or actually, hold on. If you wrote down the first example already, that's fine, but not. Here's what you want. Here's what I want you to say. We all done writing this bulk board right here? Just about the. Alright. You good? Alright. So, two things. Divided by 0, bad, always. Okay? Taking the even root of a negative number. Typically, even root means square root, fourth root, sixth root, because 2, 4, 6, 8, those are all even numbers. For the most part, you guys never have to deal with anything in this class that's over the third root or the cube root, the cubic root. Alright, so if you have to take the square root of a negative number, you can't. Okay? So, when we have this, so first I want to show you an example of what's going to happen. Alright, when you go to type something into your calculator. So let's say you have your calculator up. Alright? So you guys see your calculators, right? So, you three, just start paying attention here, and I'll get you caught up. The notes will all be online, so you can watch the weekend as well. And if you need help, you can work on help on Wednesday. Alright? So, I'm going to use this example first just to show you something. Okay? If I type this equation in, and I let this be 7, and I'm going to say x is 7. So, I'm going to type in f of 7. What's going to happen here is I go here, parentheses, 2 plus 7, parentheses, that's my numerator, divided by, parentheses, 7 squared minus 7, parentheses, 7, because I'm multiplying 7 times 7, hit parentheses, close my parentheses, and tells me I divide by 0. So that means that 7 is not in my domain. We're going to figure out how to figure that out. Algebraically. Alright? Let me show you another one. What I'm going to do now is I'm going to change all this. of 7, we'll do x equals 0. Divide by 0. 0 is not in my domain. Okay, well, how can we prove this? Because the calculator, you guys are just putting that on, put in numbers in there, and it's magic. All right? So, what did I say? To find the domain, you can't divide by 0. Correct? To find the domain, you can't take the even root of 0, or other negative numbers. You can't take the square root of a negative number. So, is this is a fraction, correct? It's 2x, or 2 plus x divided by x squared minus 7x. So, I can't divide by 0, right? So, x squared minus 7x, that can't equal 0. Does that make sense? So, since I'm dividing by x squared minus 7x, this can't equal 0. Can't. All right. That's great. So what makes that 0? That's the next question I should ask. I should be like, okay, so this can't be 0. What makes that 0? So what I'm going to say is, okay, I want to know x squared plus 7x. That's my fault. X squared minus 7x. X squared minus 7x equals 0. What makes this 0? Okay. Or actually, even better yet, let's do this. Do this instead. You don't have to erase anything. X squared minus 7x, we just said it can't equal 0, right? So, my fault. It can't equal 0. Now, this is where a lot of times factoring comes into play. Is there anything that I can factor from each of these terms? Okay. An x. So I'm going to have x times x. So I factor x in here, I have 1x left. If I factor x in here, I just have the minus 7. That can't equal 0. Okay? Now you guys have to help me here. This is very simple math. Okay? If I have one number here, it can be any number. And I have another number here, and I'm multiplying them, and it equals 0. What does one of these numbers have to be? You all cool with that? If you understand that, that makes it easy. So one of these has to be 0. Okay? This is a number, if I put a number into it, and this is a number if I put a number into it. So one of these has to be 0 to make this equal to 0. So what I know is this. I know x cannot equal 0. I know x minus 7 cannot equal 0. Okay, so x can't be 0, and x can't be 7. Those are the only two numbers that are going to make this equal to 0. So that tells me that my domain is everything except for 0 and 7. So how would I write that? Well, we like to do interval notation, or at least I personally want you to do interval notation. So let's just think about this. X can't be 0, right? Can it be less than 0? Yeah. It can be anything less than 0, right? It can be all the way out to negative infinity. So it can be, so my domain for this right here would be, typically you go to z equals capital D. So it can go all the way out to negative infinity. And it's going to keep going, so let's just say it's negative infinity down that way on the left-hand side of the number line. It can keep going. I'm up here, -5, -4, -3, -2, -1, and then 0 comes up. I can't be 0, right? Can't be 0. So I can go from negative infinity to 0. Can I be 0? So I put a parenthesis instead of a bracket. Alright? And not and. Or I can be, can I be 1? Can I be like anything like 0, can I be 0.0001? Yeah, it's just a little bit bigger than 0, so I can be anything bigger than 0, so, or I can be 0, but not 0, I can't be 0, so that's a parentheses. Or, for example, and I can go all the way up to 1, 2, 3, 4, 5, 6, 6.5, 6.9, 6.9999999, but I can't get to 7. Okay? So I can go all the way up to 7. I can't be 7. Or I can be bigger than 7, right? I can be 7.0001. I can be 10 million. So, or I can be between 7 and infinity. So the domain of that function is that. Because we found out what numbers cause me to divide by 0? Well, 0 and 7. Even numbers. Okay? So, we have 2 more examples to do before we are, well, additional practice at this time, but until we are somewhat done. Alright? So, 2 things cause us to look. When I say find the domain, you're doing 2 things. You're asking yourself, will I ever divide by 0? If it's a fraction like this, there's a good chance you might. So you better start looking to see where that's going to be 0. Is there a square root? In this case, there's no square roots. I don't have to worry about that. However, in this case, there is a square root. What was the bottom case? Bottom case is a little scary. Okay, this is a square root. What did we say we cannot take square roots of? Negative numbers, right? That's right. Can I take the square root of 0? What's 0 times 0? So the square root of 0 is 0. Alright? Is 0 negative? No. So as Moses said, 0 is not negative, so I can take the square root of it. The only numbers I can't take the square root of are negative numbers. So, right here I have the square root of t minus 5. T minus 5 is a number if I plug something into t. So it is a number. It just happens to be a variable right now. Or it just happens to have a variable in it. So, t minus 5 cannot be what?
0. I mean, negative number.
It cannot be a negative number. It has to be greater than or equal to 0. So, t minus 5 has to be greater than or equal to 0. Is this easy enough to solve? I need to get t by itself. Well, I need to know if t needs to be greater than, not t minus 5. How does that add 5? T is greater than or equal to 5. Done. That's, my domain is everything that's equal to 5 or bigger. So, how would I write that in interval notation? Bracket what? 5. Not bracket. Can I ever get to infinity? No. So it's going to be parentheses. Good. Should have that difficult. Alright. I do want to make sure one thing real quick. Do you guys know when you're solving an equation what you're supposed to do if you have inequalities like this and you divide by a negative number? For instance. You guys know what you're supposed to do? If I divide by negative 2. So when you're working with an inequality, okay, if you have to divide by or multiply by a negative number, you have to switch the sign. So it would be x less than or equal to negative 5. And if you don't believe me, don't switch the sign and start trying to put stuff in and see if it works. Because if I don't switch the sign, that would say x has to be greater than or equal to -5. Alright? So the number greater than or equal to -5 is like -4. So -2 times -4 would be 8. And then you have 8 is greater than or equal to 10, which is making you look dumb. Alright? So you have to switch the sign. That's important to remember that if you multiply or divide by a negative number, you have to switch the inequality sign. Okay? Okay. Time to make your lives visible. No one here. Start your weekends off great by being visible with this off.
Yay! Nah, I got no.
Okay, so here's my question. It's not that hard. You just have to think here. The two things that I cannot do are what? Can't divide by 0, and can't find the square root of a negative number, right? Okay. So, first thing which one is, okay, let's see if this question makes sense to you guys. Which one of those is more restricted? I would say the square root is a little bit more restricted. Alright, it's going to be, so I would work with finding the square root one first, because I notice. So this one, I have a square root, so I have to worry about that. But that square root is also in the denominator, right? So let's look at this. So it's the square root of x squared minus 9. X squared minus 9 cannot be what? It can't be negative. Because you can't, okay, so we'll get there. X squared minus 9 cannot be negative because you can't take the square root of it. So x squared.
Andre Darkhart, please report to the main office. Andre Darkhart.
Typically what we say is
Main office.
greater than or equal to 0. Because it could be 0, right? But where is this square root? In the denominator. If x squared minus 9 is equal to 0, that would be the square root of 0, which would give me 1 divided by 0. So can x squared minus 9 equal 0? No. So it's not equal to 0. Okay? So, how do we solve this? Well, we're going to go add 9 to both sides. Okay, x squared is greater than 9. Okay? Now, you guys ready? Good. This is a little tricky. All right, so how do we solve this? Now, what's the next step there? I have to go over this. It did not matter. What did you say? I gotta get rid of the exponent. Gotta get rid of that exponent. It's squared. What is the square root? So square root undoes squaring. Square root. Square root. Okay? So I'm going to get x is greater than 3. Because square root of 9 is 3. However, alright? Bear with me here. So if I go back over here, alright? I have x squared is greater than 9.
Mr. DeWall, can you please call the main office? Mr. DeWall, please call the main office.
So we already said x has to be greater than 3, right? I agree. This is part of our solution. X is greater than 3. Because if I take 4 squared is 16, 16 is greater than 9. There's no problem. If I take negative 4 and square it, negative 4 squared is 16, which is greater than 9. Negative 5 squared is 25, which is greater than 9. So -4 is less than -3. -5 is less than -3. So what I really need is x is greater than 3, or x is less than -3. Yeah. Like this? Okay, so. Okay, so I'm trying to think of the best way to explain it. So, okay, what happens is when you take the square root of a number, okay, the square root of 9 is not just 3. Because 3 squared is 9, but -3 squared is also 9. So really what you get is you get x is, so you get, if you take the square root of 9, right here, really what you get is x is greater than plus or minus 3. Right? 8. So let's just say you did this. So okay, it can be greater than, I'm gonna be honest, the explanation, the best way to explain it is just to show you how it works. So, plus and minus, we have two different numbers. So that's saying x is greater than 3, x is, and what you would think is it's saying x is greater than -3. Alright? But, what happens if you say this, is this is including like -2. If I put -2 in here, that's going to be 4. 4 is not bigger than that. If I take -1, -1 is square root of 1. 1 is not bigger than that. Alright? 0 isn't bigger than 9. 1, if I take 1, that's not bigger than 9. 2 squared is 4, that's not bigger than 9. So if I say x is greater than -3, it's giving me numbers that aren't working. So I didn't ask this, well, I know something has to work. So then I say, hey, what about -4? Well, -4 squared is 16, which is greater than 9. Alright? -5 squared, 25 is greater than 9. So I say, okay, well, those numbers don't work. So those are less than -3. So I flip it, and then it goes -3. That's kind of like a poor explanation.
So why can
Keep what positive?
x is greater than 3?
Hold on. Alright, so the trick here is that since that square root is in the denominator, it can't be 0, so it has to be greater than, instead of greater than. Alright, so the domain of this will be, okay, it says x is less than -3. So one way I like to visualize this, guys, I like to take a number line. So I have -3, and I have 3. It's less than -3. It's greater than 3. So my domain would be anything less than -3, which we start all the way out at which number? -infinity. We go all the way up to 3. Well, we can't be 3. Union. And then we start back up at 3. We go to infinity.
So basically, anything that's in the denominator, it can't can it be equal to 0?
Nothing in the denominator can ever, the denominator can never equal 0, because it is an error.
Because I don't understand the way my professor explained it.
Alright. So, those are 3 problems that give you a general idea. I'll say we're going to do these next problems. I just want to say they look like, that's what they were. Oh. They're actually not that bad. Well, no. Thank you guys. So you guys don't need to write these ones down. These will be online for you to see. But let's just think through these. Okay, first of all, let's clarify some things for your homework. Your homework is you're going to just take the assignment that you didn't do on page 9, you're going to do the rest. So you're gonna do 18 through 28 even, 29, 30, 32, 42, 46 even. You don't see me until Wednesday, so you have like 5 days. Huh? Yeah, that's pretty much on. You're just doing the not 5 days. You're doing everything that's on page 9, it's not 5 days. Okay. We do have a few more minutes, guys. Let's look at this real quick. Okay, you don't have to write these down. These will be online for you. You have, ask yourselves the 2 questions. Is there a denominator? This. Yes. The denominator cannot be equal to what? It can't be equal to 0. I was holding up one, but it can't be equal to 0. Is there a square root? No. So I don't have to worry about this whole greater than or equal to part. So, what do? Well, we just said that my denominator can't be equal to 0. So, x squared plus 7x plus 12, that can't be equal to 0. What did you guys just become masters at?
This?
Yeah. Factoring, right? Not failure. Factoring. So, what we're going to do here is factor this real quick. This factors into x plus 3 times x plus 4. Okay? Alright, that can't be equal to 0. What did we say? If we have 2 numbers that are multiplied together and they equal 0, one of them has to be 0. So either one of these has to be 0. So, x plus 3 can't equal 0. X plus 4 can't equal 0. So we have x can't equal -3, x can't equal -4. Could be anything else. So it could be -1 billion. So our domain would be equal to -50 up to -4 union -4 -3 union -3 to infinity. All right. This? Which number? These?
So you just put that in half.
I subtracted 3 from both sides, subtracted 4 from both sides. Make sense? That's only if you only have to flip stuff if it's great if you're dealing with inequalities. Okay? Let's just look at a squared minus 4 is underneath the square root, right? You cannot take the square root of a negative number. So a squared minus 4 has to be greater than or equal to 0. Right?
Good afternoon, staff and students. We have several announcements
You guys
today.
do your homework. We'll go over your homework.
There will be retail tickets for tonight's football game.